So hi guys, so in this exercise we want to see what? We want to calculate the nth derivative of the function. Now notice here that this is nth here, right? And then this means that the nth derivative of the function f of x, where for instance f of x equals the cosine of x. So, and say that in our calculations, let's say n equals 1, 2, 3, 4, 5. So we definitely know what that is, right? So we find the first derivative, which we are going to indicate for with f1 of x. The first derivative of a cosine function is minus sine. The second derivative is what? The derivative of minus sine, which is minus cosine. And then when we differentiate minus cosine, we get the function sine of x. And then when we look at the fourth derivative of x, we get cosine of x. And then we take the fifth derivative, we get minus sine of x. So now notice I circled in red the fourth derivative of f. So here. So the first, what do we notice, guys? You notice anything? The fourth derivative of x equals cosine of x. So is that equal to anything else? So what's the relationship, in other words, between the fourth derivative of f and the function f of x here? Are they the same or not? And if they are the same, can we therefore predict, for instance, the derivative of f when we take the fifth derivative of f, right? Can we predict that? Can we predict the seventh derivative? Can we predict higher derivatives for this function? So there is this, there is almost like this pattern, right? 1, 2, 3, 4, and the 4 you get back to your function, and then 5, 6, 7, 8, and then again you get back to your function, etc., etc. Okay, guys, so do you see any pattern between the derivatives of this function f of x equals the cosine of x? So let's see. That's our first question. So have you thought of anything? If so, stop this video for a second and think about it before listening to what I have to say. All right, so let's, if you have stopped and you have thought on your own, you can see, perhaps you thought about what is the fifth derivative of f, right? What is it? And we just saw that in the first slide. So you know that the first derivative equals what? And how about the ninth derivative of f? And how about the 13th derivative of f and the 17th derivative of f? So what's happening here? Is there any way that I can generalize to say 5, 9, 13, 17? Yes, there is a way. I can just say 4n plus 1, where n is 0, 1, or 2, or 3, or 4. So you see, when n is equal to 0, I get 1. When n is equal to 1, I get 5. n equals 2, I get 9. n equals 3, I get 13. n equals 4, I get 17, etc. So can I predict what this derivative is going to be like? The 4n plus 1 derivative of this function. I think you can. Good luck.